Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 9, Lesson 5 on perimeter, area, and algebra. There's a lot of connections between algebra, right, the study of variables, equations, inequalities, things like that, and geometry. As you move further in your math, you're going to use algebra more and more to solve problems in geometry as well as in a lot of other areas. In today's lesson, which is the final lesson in Unit 9, we just want to use some algebra and we want to see some connections between algebra and geometric topics that we've been looking at. So let's jump right into it in the first exercise. Algebra can help us model many geometric measurements such as perimeter and area. Exercise number 1. A rectangle is shown to the right that has a length of 8 inches and an unknown width represented by the variable w. Letter A. What would the expression below calculate for the rectangle? Explain. So what would the expression 2w plus 16 calculate for this rectangle based on the value of the width w? Pause the video now and see if you can figure that out. Well, there's really only two things that we know about a two-dimensional figure, and that's its perimeter and its area. And this expression calculates the perimeter, right? Now, the reason that that expression would calculate the perimeter is because it is the sum of w plus 8 plus 8, right? If I want the perimeter of any figure, not just a rectangle, I'm going to add up the lengths of all its sides. But for a rectangle, right, this rectangle in particular, we would have two sides that were 8 inches long and two sides that are an unknown w inches long. So if I add w plus 8 plus 8, the w plus w, when I combine like terms, will be 2w, and the 8 plus 8, when I just combine 8s, will be 16. That's it. It's just an expression for the perimeter of that rectangle. Now, letter B. If the width w is equal to 2 inches, evaluate the expression above and give an interpretation of your answer with units. All right, great. So if w was 2 inches, what would that expression be equal to? And then what does that number tell us? Pause the video now and figure out both. All right, well, it's simple enough to actually evaluate it. We're just going to take 2 and substitute it in for w. We have to do the multiplication first. 2 times 2 is 4, plus 16 would give us 20. Now, that's the answer to what the expression is equal to, but what's the interpretation? Well, the interpretation would be the perimeter of this rectangle is 20 inches when its width is 2 inches. That's it, right? And we should know that interpretation sort of based on our answer from letter A, right? Once we identify that this expression calculates the perimeter, then as soon as I put in a value of w, then the answer that comes out is the perimeter with that particular width. All right, let's now work a little bit with some area here, okay? And I redrew the picture down here just so we wouldn't have to keep looking up above. Letter C. Write an expression for the area of this rectangle in terms of w. All right, well, this is a very simple expression, all right? But I'd like you to write something down for the area of this rectangle in terms of w, which means your formula is going to have a w in it. Pause the video and think about this for a second. Well, area is always length times width. We know the length, it's 8 inches. We don't know the width, we call it w. So the area is simply 8 times w, or 8w. Remember, whenever we put a number right beside a variable, that implies that we're multiplying the two together, and since area is simply this times this, there it is. Now let's take a look at letter D. If the area of the rectangle is 28 square inches, Use algebra to find the width of the rectangle. Show your work. Awesome. Well, we know what the area is. It's 28 square inches. So what we're now going to do is take our expression, 8w, and we're going to set that equal to 28. Easy enough. So this is sort of an equation that models the fact that the area is given by 8w and we're told it's 28 square inches. I'd like you to pause the video and now solve this for w. You're going to get a mixed number as an answer, and I'd like you to express that answer in simplest form. Pause the video now and go ahead and finish this. All right, let's do it. It's simple enough, right? It's a one-step equation. Since we multiplied w by 8, to undo it, we have to divide by 8. Now, 28 divided by 8 is not a nice number, right? If this was something simple like 24 divided by 8, great. The answer would be 3. But 28 is not evenly divisible by 8. So I say to myself, right, how many times does 8 go into 28? And that's going to be 3 times, right? And when it does, that's going to be 3 times 8 is 24. It's going to leave me with a remainder of 4. So I'm going to have 3 and 4/8. Now my only question is whether or not the 4/8 is simplified, and it's not. 4/8 is just another way of saying the fraction 1/2. So in that case, my answer is 3 1/2, and we should not forget units, inches. And this is where algebra is very, very helpful. Again, it's simple enough. If I told you I had a rectangle that had an area of 24 square inches and it had a length of 8 inches, you could probably very easily say the width was 3 inches, right? On the other hand, when the width or the length doesn't nicely divide into the area, then algebra is very helpful to be able to think about how we find the missing dimension based on the one dimension we know and the area. All right, let's keep working with things. Now remember, today we're really just exploring kind of connections between geometry and algebra. And the connections between them are so common that sometimes terminology, which is just a fancy word for words, often moves from one subject to another. So let's kind of take a look at that in the context of squares. Let's see exercise number 2. Consider the most basic rectangle, a square. Letter A, find the area of each of the following squares. This should be a piece of cake. So I'd like you to pause the video right now, find the area of each one of these things, don't forget proper units, and then we'll move on to letter B. All right, well, because squares are rectangles, their areas can always be found by doing length times width or base times height or whatever you want to call the letters. So in this case, we would have simply 1 times 1, which would equal 1 square centimeter. Right here, we would have 2 times 2, which would be 4 square centimeters. And here we would have 3 times 3, which would be 9 square centimeters. And again, never forget, right? Never forget, the whole idea is that we're really counting how many squares that are 1 by 1 that fit inside of these things. So there's 4 that fit inside of here, 9 that fit inside of here, and only 1 that fits inside of that. Granted, these pictures are not drawn to scale. So if you're saying, well, there aren't 9 of these that fit inside of that, that's because this one's really not properly scaled compared to that one. Now, what's the point? Let's take a look at letter B. If S represents the side length of a square, write a formula for the area of the square. In other words, if I had a square that instead of was 1 by 1 or 2 by 2 or anything like that, it was S by S, then what would be the area of that particular square? Well, it would obviously be, just like before, S times S. And that's a great formula, but remember, anytime we have a variable that's multiplying itself, we can then use an exponent to represent that repeated multiplication. And here's where that terminology goes from one area of math to another. You will almost always hear a math teacher say this formula as the following: S squared. They won't say S raised to the second exponent or S raised to the 2 or anything like that. They'll say S squared. They will literally use that terminology. S squared. The second exponent is called the squared exponent because it's literally as if we are taking a number and finding the area of a square that has that particular number as its side lengths. And it's really cool. Not only does it do this, but it gets into what are known as the perfect squares in numbers. So even in the field of numbers, we get that. Numbers that could be the area of a square whose side length is a whole number are known as perfect squares. So I'd like to just visit the perfect square numbers. They're extremely important in math, all right? As you move on and move forward, right, you get all these kind of numbers, even numbers, odd numbers, multiples of 5, all sorts of different numbers, right? But the perfect squares are very important, right? And we can figure out the first 10 perfect squares by just doing a bunch of products. So the first perfect square we can find by doing 1 times 1. The next perfect square we can find by doing 2 times 2. So both 1 and 4 are perfect squares. All right? In other words, they could be the area of a square, right, whose side lengths are whole numbers. The third perfect square, 3 times 3 would be 9. The fourth perfect square would be 4 times 4, or 16. All the numbers that I'm circling are the perfect squares. Why don't you find the remaining 6? Now, I want to be very clear. There's an infinite number of perfect squares. I'm just asking you to list the first 10. So here we go, right? The next one will be 5 times 5. 25 is a perfect square. 6 times 6. 36 is a perfect square. 7 times 7. 49 is a perfect square. 8 times 8. 64 is a perfect square. 9 times 9. 81, that's a perfect square, and 10 times 10, 100. I'll leave it. Kind of looks like the number 100. 100 is a perfect square. And again, they keep going. 11 times 11 gives me 121. That's a perfect square. 12 times 12 is 144. That's a perfect square. 13 times 13 is 169. That's a perfect square, etc. But all of these numbers that are circled literally are given that name, perfect square numbers, because they could be the area of squares. Squares that have whole number side lengths, that is. All right, let's keep going and play around a little bit more with algebra and geometry. Now, when we move into the realm of triangles, that can be a little bit trickier because the area of triangles, right, always involves that factor of 1/2 sitting out in front. So let's play around a little bit with that in exercise number 4. The area formula for a triangle is A equals 1/2 BH, where B is the length of the triangle's base and H is the height of the triangle to the base. Letter A, find the value of the area if B equals 16 and H equals 9 inches. Use appropriate units. All right, so it's important. Very often you will be given geometric formulas, some of which you just have to have memorized, but sometimes they'll give you a formula. Then they'll give you the values that you're supposed to plug in the formula, and you have to figure out the answer. So take a moment and figure out the area of a triangle whose base is 16 and whose height is 9. Pause the video and do this in a moment. All right, well, simple enough. I'm just gonna literally plug these numbers in. We've found plenty of areas of triangles lately. I have 1/2 times 16 times 9. I think I'm going to do the 1/2 times 16 first to get 8, and then I'll do 8 times 9, and that will give me 72 square inches. All right, easy enough. Now let's get into the algebra portion. Letter B. If B equals 24 centimeters and the area is 48 square centimeters, set up and solve an equation that can be used to find the height, h, of the triangle. All right, so this is classic algebra, right? I mean, I know one of the two lengths, I know the base, I know the area, and I want to find the other one. So what I'd like to do in this case is I'm going to just put down 1/2 times 24 times the height is equal to 48, right? And that's truly the formula that I want to use now to solve for the height. Pause the video now and see if you can solve this equation for h. All right, well here's where it's really nice to use what I call the associative property and what everyone calls the associative property. I didn't make that term up. What everyone calls the associative property of multiplication. In other words, I'm going to do 1/2 times 24 first, which is 12, and now I have 12 times h is equal to 48. Once I do that, then this is a very simple one-step equation to solve. All I need to do is divide both sides by 12. 48 divided by 12 is 4. I want to watch my units. In this case, my length units are centimeters, so the height must be 4 centimeters. That's it. Nice and easy algebra there. Let's look at a trapezoid in our final problem, which is a bit more challenging. All right, here we go. Exercise number 5. An isosceles trapezoid is shown below with the two parallel sides having lengths of 20 inches and 12 inches as shown. The height is unknown. The area of the trapezoid is given by the expression 1/2 times 4 times h plus 1/2 times 4 times h plus 12h. All right. First part of the problem asks us to simplify this expression by combining like terms. Now, just really quick, before we do any of that, which is relatively easy, I just want to give you a quick explanation of where this comes from. In the last lesson, actually a couple lessons ago, we worked with trapezoids, and specifically we worked with an isosceles trapezoid. So the idea here, right, is that if I drew in this rectangle, right, where that would also be h, I would have 20 minus 12, which is 8, and then I'd have 8 divided by 2, which is 4. So the idea is, right, that the area of this triangle would be 1/2 times 4 times h, that's this. The area of this triangle would be 1/2 times 4 times h, that's this. And then the area of the rectangle would simply be 12 times h, and that's this. What I'd like you to do is try to simplify this expression by combining all like terms. And as a suggestion, what I would first do is do the 1/2 times 4 and the 1/2 times 4. But then try to gather up all the like terms. You should have a very simple monomial, a single term expression when you're all done. Go ahead and play around with that. All right, well, just kind of working up here. If I do 1/2 times 4, I get 2. And 1/2 times 4, and I get 2. So the area is going to be 2h plus 2h plus 12h. Well, again, I'm just keeping track of how many h's I have. I've got 2, 4, 16. So 16 times h gives me the area of this particular trapezoid. Now let's take a look at letter B. If the area of the trapezoid is 112 square inches, set up and solve an equation to find its height h. All right, why don't you pause the video and see if you can figure out what the height of this trapezoid must be, given that this is its area formula now, and that's its area. All right, well, it's pretty simple. It's very similar to what we did in the last problem. I must have the area, which is 16 times h, equal to 112. So now to solve for h, again, we're just going to divide by that 16. All right, and now we need 112 divided by 16. Now that is just simply 7, right? And you can figure that out by doing long division or by kind of doing guess and check. Oh, I should make sure I put units on. 7 inches. All right, so just a little bit of algebra to determine the height of a trapezoid if we know its bases and its area. Let's wrap this up. In future courses, Math 7, Math 8, high school geometry, even high school algebra, you're going to use algebra a lot to help you solve geometry problems. In fact, again, the connections between algebra and geometry are so strong that you get this kind of this sort of carryover between terminology. And the best example of that is when you talk about squaring a number, that is multiplying a number by itself, and something we didn't look at today, but we might in the next unit, cubing a number. And that's when you multiply a number by itself 3 times. And that would give you the volume of a cube. But we'll talk about that a little bit more in the next unit when we get into solids, their volumes, and their surface areas. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.